when it comes to classification, the benchmark is naive rule. So that is, classify all the records as belonging to the most prevalent class. Suppose if you have a data set of that 5% is 5% is event, 95% is non-event, right? So you have transactions coming in, credit card transactions, and most credit card transactions are valid transactions, but there are some fraudulent transactions. So if you use naive rule, which is what is the most prevalent class? So most prevalent class is 0, non-event, event being a fraud, right? So if you use naive rule, you will classify everything as non-event. Everything is valid. Okay, but that would be the benchmark. Your methodology that you're going to use should be able to do better than that. Okay? Otherwise, it's not worth it. So there are some wrinkles here, and we'll talk about those in a little bit. Okay, so how well a particular model does depends upon the predictor values. When you plot the predicted values, how well the predictor values separate based on the class. So class separation of records, if the classes are well separated by the predictor information, then even a small data set will be able to do a very good job of being a good classifier. But if the class are not separated in the predictors, so when you plot the predictors, if all the predictor values belonging to class 1 are on one side and everything else is on the other side, so that means there is good class separation. So for example, here you see owner and non-owner, and you're plotting the two predictors, income and lot size, and you see it's not perfect, but if you have a 45-degree line like this, it's going to separate the owners and the non-owners quite well. So this is high separation of records. Whereas something like this, where you have these, if the dark ones are events, so that there is separation, but it's kind of it's and there are a lot of non-events here, and so I wouldn't say it's completely useless in terms of separation, but it's not like here. Okay, this is not as good. There is medium separation, maybe low is a little extreme, but not very good separation. So in these cases, even if you have large data sets, you may not be able to come up with good classifier. So how good a classifier turns out to be sometimes is based on the underlying data, how well separated the classes are within the predictor values. So what we need to do is to be able to come up with the best possible model given the constraints of the data itself.